Let's expand what we know about the sum and difference formulas and create double and half angle formulas. Now, I'm going to expand each of these using sum formulas. You might say, well, how are you going to do that? I know that 2 theta would be the same thing as theta plus theta. Now I can use the sign of a plus b or the sign of x plus y, however you like to think about it, formula. So I know the jingle is sine theta cosine theta plus sine theta cosine theta, sine A cosine B plus sine B cosine A. And then what I have are 2 like terms. So this just becomes 2 sine theta cosine theta. Therefore, if I want to summarize, then I know that sine of 2 theta is condensed, and now I know I expand it into 2 sine theta cosine theta. Let's do the same thing with tangent and cosine of 2 theta. Because if you take the time to expand them, they do tend to stick with you a little bit better. So I will say on this one, I'm dropping just to make some more room. Again, I'm going to expand it into cosine theta plus theta. And I know it's cosine cosine minus sine sine. So cosine A cosine B minus sine A sine B. Well, cosine theta is cosine squared theta minus sine sine would be sine squared theta. Now this is one of 3 representations. This cosine squared minus sine squared could actually be rewritten 2 different ways. So I'm going to recopy cosine squared minus sine squared. Now one thing I could do is say let me sub out cosine squared theta using a Pythagorean identity. Well, cosine squared is the same as 1 minus sine squared if I use the Pythagorean. And then I have 1 minus 2 sine squared theta. So there is a second way that you might need to expand cosine 2 theta. And it really depends on the problem. You might find sometimes that it's easier in an equation, for instance, on next chapter, to use one of these 3 ways over another of the 3 ways. So I'm going to do the same thing, but instead of subbing out cosine squared, let me sub out sine squared using a Pythagorean identity. So I have cosine squared minus, and then I'm going to have parentheses. Sine squared is the same thing as 1 minus cosine squared. If I distribute my negative, I get negative 1 plus cosine squared. And then when I combine like terms, I get 2 cosine squared theta minus 1. So these do take memorization. There's no getting around that. Let me summarize what I've got now. So for cosine 2 theta, there's 3 expansions. The first one that you need to know is cosine squared minus sine squared. And then you can always alter this one to get the other 2. But the other 2 are 2 cosine squared theta minus 1 and 1 minus 2 sine squared theta. You do need to, by a couple of days from now, have all 3 forms of the expansion memorized, because you'll need it to make your life easier when you have to sub in one of the expansions. But also when we do recognition problems, you need to recognize if I give you, for instance, 2 cosine squared 15 degrees minus 1, you want to recognize that would be cosine of 2 times 15 degrees or cosine 30 degrees. We'll do what I just said. We will actually do problems like that, to where I will write down and we will practice what I was telling you. So last but not least, I'm going to make this tangent of theta plus theta. I know that tangent of A plus B is tan A plus tan B over 1 minus tan A tan B. So let's do a little cleanup work. On the top, tan plus tan is 2 tan. On the bottom, 1 minus tan tan is 1 minus tangent squared. So that is your third identity. So if you know the sum formulas, the double angle formulas are really pretty manageable. Now the half angle formulas you'll find are a little bit more difficult to develop and then to remember, but I know that you can do it with some practice. So this is 2 tan theta over 1 minus tangent squared theta. So that's your summary of formulas that you're going to work on memorizing starting today, and you want to have them by tomorrow, at least the first form of the cosine 2 theta plus the sine 2 theta, tangent 2 theta formulas. Now, let me show you where the half angle formulas come from. What you really do is cleverly manipulate the double angle formulas. So if I start out with the idea that cosine of 2x, I'm right here. If I start out that one way that I could expand cosine 2x is to rewrite it as 2 cosine squared x minus 1. We just learned that that's one of the 3 expansions. And then I sub in and say, let me replace 2x with theta, which means that 1x is going to be theta over 2. Then I rewrite what was cosine of 2x becomes cosine of theta. And what was 2 times cosine squared x becomes 2 cosine squared theta over 2. And the minus 1 and the minus 1 are both still there. Now what I can do is simply solve for cosine of theta over 2. So I'm going to go from here, and I'm going to say 2 cosine squared theta over 2 minus 1 equals cosine theta. The first thing I need to do is add 1. And I could write that as 1 plus cosine theta or cosine theta plus 1. Either one's fine. Now I need to divide both sides by 2. So I could write it as 1 plus cosine theta all over 2. Or I could write it as 1/2 1 plus cosine theta. Again, either one is fine. And in fact, sometimes you might find it more helpful to write it one way and sometimes one more helpful to write it the other. So now what I need to do is I need to take the square root of both sides. So whenever I take the square root of both sides, what happens is I get plus or minus the square root of 1 plus cosine theta all over 2. Or I could rewrite that as plus or minus the square root of 1/2 times 1 plus cosine theta. Again, sometimes you'll find maybe that one's easier to deal with than the other. And so it doesn't hurt to know them, that they're equivalent forms. I'm not going to derive sine of theta over 2, but because it's a lot the same thing. But if I wanted to derive sine theta over 2, I'm going to make this note, but we're not going to do the whole problem. To derive sine of theta over 2, you do a similar thing, but you start with the idea that cosine 2x could be expanded into 1 minus 2 sine squared x. And then you follow the same steps. You would say, okay, I'm going to make 2x theta, which makes 1x theta over 2, and you go from there. So the steps are very, very similar to what you just saw me do for cosine theta over 2. If I wanted to derive tangent theta over 2, I would simply take the formula for sine theta over 2 and the formula for cosine theta over 2, and I would clean those up. Well, let's summarize at this point what you need to know about the half angle formulas. So cosine of theta over 2, you could write as cosine of 1/2 theta if you think that that's going to help you remember that it's a half angle formula. Either way is fine. I can rewrite that as plus or minus the square root 1 plus cosine theta all over 2. And that's also equal The form is the same. It's just algebraically I'm rewriting it just a little bit. 1 plus cosine theta times a half, all into the radical. Now, I told you that sine of theta over 2 works out similarly, but I did not already show you what the formula is. But what it works out to is plus or minus, and instead of 1 plus cosine, it's 1 minus cosine is the way that would work out if you actually continued that derivation that I started on the previous page in red. Likewise, you could say 1/2 and say 1 minus cosine theta. Sometimes one of those forms is just easier algebraically to deal with. Now, tangent theta over 2 is one of the nicest formulas we've got. It actually works out to 1 minus cosine theta all over sine theta. Now, I will show you that this can be rewritten as sine theta over 1 plus cosine theta. And I'm going to erase this, and the reason is it's always simpler to work with a fraction with a monomial denominator, because then you have the options to separate and reduce or to multiply by the reciprocal. And so this second option for me is never something I go to. So in fact, I'm even going to say, let me erase it and just memorize the one version. It would be my suggestion. You've already got 3 versions of cosine 2 theta to know. So I would just say cut it down to this one version for tangent theta over 2. So let's practice drawing the triangle that demonstrates the given information, expand, and evaluate. We did some of these yesterday with the sum and difference formulas. So the given information says that tangent theta equals 24/7 and theta is in quadrant 3. Okay? I'm going to draw the information. If theta is in quadrant 3, then I'm going to put theta here. Tan theta is opposite over adjacent. And this is a 7, 24, 25 Pythagorean triple. And yes, knowing your triples does make life easier for you. Well, I need to evaluate sine 2 theta, but I don't know anything about 2 theta. I do, however, know how to do sine of theta, cosine of theta, tangent theta. So what I do is I expand into 2 sine theta, cosine theta. And now, sine of theta I can look at and say sine theta is opposite over hypotenuse, 24 over 25. And it's negative because you're in the tangent quadrant. Cosine theta is 7 over 25. That's adjacent over hypotenuse. And it's also negative because we're in the tangent quadrant. So then what I've got is 2 negatives will make a positive, and 2 times 24 times 7, I'm doing on my calculator, is 336. 25 squared, I know, is 625. Now you might be asking, wait a minute, I thought this is a no calculator test. You are correct. And so on the test, I will give you smaller numbers. I won't give you these large numbers to deal with. Now, the half-angle formulas for problems like this, in my opinion, are the most difficult thing to sort through on the entire test. What you need to do is, I know that I'm going to expand this into plus or minus the square root. I will tell you, I generally think it's easier on these to work with 1 plus cosine theta times a half rather than 1 plus cosine theta over 2. But here's the deal. You don't use plus or minus. You use either a plus sign or you use a minus sign. So you must choose plus or minus, not both. And to me, that's the most conceptually difficult thing you need to do. The rest of it, you can work out with a lot less difficulty, I think. So here's what I need to do. I'm going to look at it and say, well, in the given problem, theta falls in the third quadrant, which means theta falls between 180 degrees and 270 degrees. If I take half of all three parts, then I get 90 degrees is less than theta over 2, and that's less than, I think that's going to be 135 degrees. Well, that means theta over 2, if it falls between 90 and 135, that means it's going to have to fall in the second quadrant, or the sine quadrant. So now I know that cosine of an angle in the sine quadrant will be negative. So I am going to take the positive option off the table. I now have determined that the answer must be negative. So everything else from here on out is straightforward. That was the hard part. So let's work out the rest. So I've got 1 plus. Now this cosine theta means use the original picture. And I already know that cosine theta is negative 7/25 because I inserted that value on the previous problem. So that's going to give me 1/2 times, let me change the 1 to 25/25 minus 7/25. And I know that 25 minus 7 is 18. So now I've got half of 18/25. And I know half of 18/25 would be 9/25. And now I've got a fraction that I can take the square root of really simply. And so your answer is negative 3/5. And these usually start messy, but normally clean up surprisingly easy. Now, sometimes you might have something like the square root of 1/10 as the final number under the radical. Remember, that's the square root of 1 over the square root of 10, and then you make that square root of 10 over 10. But that's normally about as messy as the answers might turn out. That's obviously not the case in this problem. This half-angle problem it worked out real nice and neatly. So let's do a few more of these. Tangent 2 theta. Well, hopefully you know you've got to expand. This is 2 tan theta over 1 minus tangent squared theta. So sometimes just working out the fractions is messy, so that's what we're doing. Well, remember, I gave you already tangent theta is 24/7, so you don't even have to look at the picture. You can just plug in what I'm giving you. So 2 times 24/7 all over 1 minus 24/7 squared. So that's going to take some work. On the top, I've got 48/7. Now on the bottom, I have 1 minus 24 squared, if I'm correct in my memory, is 576. 7 squared is 49. Now, normally what I'll do is I'll hold off and I won't write the 1 until I know how best to write it. I now know a better way for me to have written the 1 would have been to have written it as 49 over 49. So where am I now? Well, I can say this gives me 48/7 over, now 49 minus 576, and again, these are big numbers and I'm using my calculator. And I will not put such large numbers on the test if the test is a no calculator thing. So it's fine right now. We can use them in class, and I'm telling you I'm using the calculator. Notice that I am flipping, multiplying by the reciprocal, flip and multiply. So let's see what happens. The 7 goes into 49 7 times. Let's see, 527, the digits add up to 14, so 3 will not go into 527. 2 doesn't go into 527. I don't think 48 over 527 reduces. Therefore, I'm just going to say, well, 48 times 7 on the top is negative 336 over 1 times 527 on the bottom. I think that's my final answer. Now, usually people see the tangent or the half angle formulas and kind of freeze up and go, oh, the half angle formulas are so much more difficult to memorize and they're so difficult to use. That's true for sine and cosine theta over 2. Tangent theta over 2, though, is one of our best formulas. I'm going to expand into 1 minus cosine theta over sine theta. And this is actually far easier to work with than the tangent of a plus b or tangent of a minus b. So this is a good thing. So I've got cosine theta. Remember, I have used cosine theta twice now. Cosine theta is negative 7/25. Sine theta is negative 24/25. So this is 1 minus negative 7/25. And I just said sine theta, when I look back at the picture, was negative 24/25. Well, on the top, do you see that it would be 25/25 plus 7/25, which you could just do in your head. You don't have to write this extra step. And I know 25 plus 7 is what, 32/25? Are you all right if I go ahead and flip and multiply and say I can flip this to 25 over negative 24? 25's cancel. Then you've got negative 32 over 24, divide by 8, and you've got your answer. So really, that's a lot easier to use than the tangent formulas you dealt with yesterday. Woohoo! All right, now that you're past that kind of problem, let's look at simplify and evaluate. So the recognition skills are really important here. And what I'll do is I will write what formula you need to compare these to in red beside the problem. So for instance, I'm looking at this problem and saying, forget numbers for a minute. This is 2 sine theta cosine theta. Oh, do you recognize that that's the expansion of sine 2 theta? So I need to recognize, simplify what I'm going to write in black, and evaluate, if possible, without a calculator. So I'm going to simplify this to sine of 2 theta. Well, theta in this case is 5 pi over 8. So this is sine of 2 theta, because the 5 pi over 8 is in place of theta in the original problem. So that is sine of 5 pi over 4. Wait a minute. 5 pi over 4 is one of my major angles that falls in the tangent quadrant. So I know it's negative. I know the reference angle is pi over 4. And I know sine pi over 4 is square root 2 over 2. I can do that. So I recognized it, I simplified it, and I evaluated without a calculator. We'll take a look at the next problem. I'm looking at this and saying, forget numbers. Let me just write that as 2 cosine squared theta minus 1. Oh, do you recognize that that is one of the 3 expansions for cosine 2 theta? This is why you do need to know all 3 expansions of cosine 2 theta, because if you don't, you won't recognize what I'm giving you here. So I need to simplify what I'm given. So I'm going to simplify this to cosine of 2 theta. Well, what's my theta here? Pi over 12 is in place of theta on the original problem. Well, what is 2 times pi over 12? Pi over 6. So I've now recognized and simplified the given information. And remember, cosine pi over 6, cosine 30, you know that. That's square root 3 over 2. Now, on the next problem, I need to recognize, oh, this is one of these crazy half-angle formulas, I think. If I look at it as 1 minus cosine theta all over 2, do you recognize that as the expansion for sine of 1/2 theta, or sine of theta over 2? Whichever one of these makes more sense to you is the one you need to write down. So I remember that if there's a plus right here, it's cosine. If it's the opposite sign, then it's the other trig ratio, it's sine. Anyway, now I'm going to recognize I need to simplify what was given. So I am going to write this as sine. I think I'll use half theta. And my theta here is 540. Because remember, this 540 is in place of theta in the red formula. Well, what is half of 540? 270. Oh, sine 270. I know. Now I'm not using a triangle. I'm just saying sine of 270 falls there on the axis, and that's -1, using my 1, 0 circle. Now, same thing on the next problem. I'm going to sub in 1 minus tangent squared theta over 2 tan theta. Oh, yeah, that is the formula for, wait a minute. That's not exactly a formula. That's like upside down of a formula. This is the same as 1 over 2 tangent theta over 1 minus tangent squared theta. Because remember, 1 over a fraction means the reciprocal. Why did I do the reciprocal? Because this 2 tan over 1 minus tan squared, that's a formula I know. This would be 1 over the 2 tan over 1 minus tan squared. That's tangent 2 theta. Oh, and what's 1 over tangent? Cotangent. Boy, now that one was trickier. You had to really have your eyes open for that one. Well, now that I've recognized it, let me simplify what was given. What was given was cotangent of 2, what's in place of theta? 67.5 degrees. And let's see here. 2 times 60 is 120. 2 times 7.5 is 15. So that just means cotangent of 135. And again, 135 is a major angle that falls in the sine quadrant. So I know it's negative. Tangent of 45 degrees, which is your reference angle, is 1. So cotangent's also 1. So I enjoy the recognize, simplify, and evaluate because I think they're kind of like recognizing puzzle pieces and what can you do. Now we're to the point where we're actually going to evaluate more angles without calculators. So we added some angles yesterday. We're going to add a little bit more today. Here are tips, and you'll see that I'll come back to these tips as I work the problems. If you ever have a choice of choosing between, and you'll notice that I am right here, choosing between using sine of a plus b versus sine of theta over 2, or choosing cosine of a plus b versus cosine of theta over 2, you might say, when would you have that choice? For instance, if I said, let's do something as easy as cosine of 15 degrees. Well, I could write that as cosine of 30 degrees divided by 2, and then use a half angle formula. Or I could write it as cosine of 60 minus 45 degrees, and then I would use a sum difference formula. For sine and cosine, the sum and difference formulas are easier. This opposite is true with tangent. So notice on the second tip, if you have a choice of saying tangent of a plus b or tangent of theta over 2, in this case, it's easier. And again, it would be the same situation, maybe tangent of 15 degrees or tangent of 75 degrees. So if I said, let's do tangent 75 degrees, then you could write it as tangent of 150 all over 2. Or you could write it as tangent of 30 plus 45. In this case, the half angle formula is actually the easier one to get through. So I will use those concepts as we work the following problems. Now, if you ever see a 0.5, if it ends in 0.5, it's got to be half of a 45. That's the only way to get the decimal. So 22.5 is half of 45 degrees. Or it's 45 degrees over 2, if that's your preferred way of writing it. There is no other way. I cannot combine multiples of 30s and 45s and 60s and come up with 22.5. So I don't have a choice. I must use the half angle formula. Now remember, 22.5 is in the first quadrant, so I know that sine of 22.5 is positive. Why am I telling you that? Because you don't say plus or minus the square root of 1/2 times 1 minus cosine theta. You don't say plus or minus. You choose one. And I choose on this one positive because I can already tell from the problem that the answer is going to be positive. So don't leave the plus or minus. Always fix that immediately so you don't forget to fix it. Well, let's see here. More specifically, this is 1/2 times 1 minus your theta in this case, because remember, this is sine of 1/2 theta. So your theta and your 45 correspond to each other in this problem. Well, fortunately, you know how to do 45. Cosine 45 is square root 2 over 2. Meaning that I think the 1 should be written as 2 over 2. Now where are you in the problem? You're going to get 18 million 2's. If I combine these two fractions on the inside into one fraction, it's 2 minus the square root of 2 all over 2. Now, that's going to give me, if I multiply, across the top I've just got 2 minus the square root of 2, but across the bottom I've got 2 times 2 is 4. That gives me the final answer, because the square root of the top is just the square root of 2 minus the square root of 2, and there's nothing I can do with that. But the square root of the bottom is just 2. So you're going to have lots of weird answers that have radicals into radicals. What are your 4 options? Because you by now probably know there are usually 4 ways the signs can play out. So here are your 4 options, and then I'm going to erase this. For a problem like this one, it could have turned out 2 minus the square root of 2 all over 2. 2 plus the square root of 2 all over 2. Negative on the outside, 2 minus the square root of 2 all over 2. Or negative 2 plus the square root of 2 all over 2. So you still have the 4 options with your signs, and the numbers are going to be lots of 2's. There's a case later that you'll see where the options have 3's in them. But you get the same issue with the signs varying and giving you a total of 4 options. Now, you need to be recognize that pi over 8s are always half of pi over 4s. So this is the same thing as cosine half of 7 pi over 4. If it was a pi over 12, you would write it as half of a pi over 6. So when I do that, I'm like, okay, I got to use the cosine of 1/2 theta formula. So let's see here. Plus or minus the square root of 1/2 times 1 plus cosine theta. That's the formula I'm using. Okay. Now, 7 pi over 8. Let's see here. 7 pi over 4 is the same thing as 315 degrees. If I take 315 and divide it by 2, this is the same thing as cosine of 157.5. Now 157.5 is an angle in the second or the sine quadrant, so I know that cosine of 157.5 will be negative. Again, why am I doing all that rigmarole? Because I cannot leave the plus or minus. I have to choose a sign, and I choose negative. Now I'm going to go from there. How do I finish the problem out? Well, I've got negative 1/2 times 1 plus. Now, cosine theta would be the same thing as cosine 7 pi over 4. 7 pi over 4 is what's in place here and here. It's what's in place of theta. Well, how do you evaluate cosine 7 pi over 4? The way you always have. 7 pi over 4, remember, is in the cosine quadrant. So cosine of 7 pi over 4 stays positive. It's positive root 2 over 2. Now, can you start to see that the fraction that you're going to get I'm going to erase that and move it out a little bit wider. The fraction you're going to get for this binomial is 2 plus the square root of 2 all over 2, so you start to burn some steps. And can you see, across the top you're going to have a negative in front of the radical, 2 plus the square root of 2. Across the bottom you're going to have the square root of 4. Go ahead and make it 2. And that, hopefully you'll start to get used to the numbers where you can burn some steps and not write so much. These are not easy problems. They are tedious. There's no doubt about it. Now, you're not seeing double. I really do have the same problem twice. Let's think about our options. Well, we're on double angle and half angle day. So I might say, well, what is 165 actually half of? Well, 165 times 2 is 330 degrees. So I could do plus or minus, and I know I've got to choose the sign, 1/2 of 1 plus cosine theta, which would be cosine 330. And I could proceed from there. On the next one, I could drop back and say, didn't I do problems like this yesterday? Like, could I break this up into 120 plus 45, for instance? Aren't there multiple ways I can make it a sum or a difference problem? Yes. So you tell me, which do you think is easier? Because if I do the sum formula, I know I say cosine cosine minus sine sine. I hope that you realize that the easier method would be this one, because I don't have to deal with radicals under radicals, which is unpleasant at best. So I'm going to, with sine and cosine, when I have a choice like I do on this one, defer to the sum and difference formulas because they are easier. So cosine 120 must be negative because it's in the sine quadrant. The reference angle is 60. Cosine 60 is a half. Cosine 45 is square root 2 over 2. Sine of 120 is positive because it's in the sine quadrant. Sine 60 is square root 3 over 2. Sine 45 is square root 2 over 2. Do you see that that's negative square root 2 minus the square root of 6 all over 4? And because 165 is in the sine quadrant, did we not know it was going to turn out negative? And does the answer I got not turn out negative? So remember, that's just a quick check method. All right, I'm going to fly through the other ones so you see it once, and then you're going to remember, ooh, that is not the better method. So on this one, again, I know this is negative, so I erase the positive option. It's not going to be the one I use. So I have negative 1/2. Cosine of 330 is positive because it's in the cosine quadrant. The reference angle is 30. Cosine of 30 is the square root of 3 over 2. I make this 2 over 2 plus the square root of 3 over 2, which gives me 2 plus the square root of 3 all over 2. On the top, 1 times 2 plus the square root of 3 is 2 plus the square root of 3. It stays on under the radical. On the bottom, 2 times 2 is 4. But if you do the square root of 4, you get plain old 2. So my question is, do you know why this negative 2 plus, or negative square root of 2 plus the square root of 3 all over 2 equals this value? That might be a good problem for us to look at tomorrow. Anyway, this one is not only easier to get, it's easier to use when you have to plug it in and work with it like you'll be doing in the next couple of chapters. So sine of 11 pi over 12. Circle the easier method. Well, on this one, there actually is two different methods. Think about it. This is sine of half of 11 pi over 6. Well, wait a minute. 11 pi over 6 is 330. Half of 330 is 165. This is the same as sine of 165. And did we not just do cosine 165? So that means I could do this one as 120 plus 45 a lot like I did on the last problem. Are you good that with sine and cosine, this is easier? I'm hoping that you could finish that on your own. Let's move on because I know you're probably fatiguing a little bit with watching the videos. On this one, I have to remember that a pi over 8 is a half of a pi over 4. Now, are there two options on this one? Well, 7 pi over 4, remember, is 315. If you divide that by 2, this is the same thing, and I did this earlier, as 157.5. If your angle is a 0.5 angle, you've only got the one option. So the only way to work this one is with the half angle formula. Well, what's the half angle formula? Because remember, this is tangent of 1/2 theta. The half angle formula is 1 minus cosine theta over sine theta. This is the best formula we've got anyway. I want to use it. Even if I had a choice, I would have used it. Well, that's 1 minus, in this case, 7 pi over 4 is in the role of theta. And I'm going to show you something that's going to help you. You don't have to do this, but it will make it faster. Cosine 7 pi over 4 is positive. In fact, it's positive square root 2 over 2. But remember, square root 2 over 2 is the same as 1 over square root 2. And I am actually going to suggest that you use the 1 over square root 2 because it's going to make it easier to flip and multiply. Sine of 7 pi over 4 is negative because we're in the cosine quadrant. 1 over square root 2 over 2. Now what I've got is the top multiplied by the reciprocal of the bottom, and the reciprocal of the bottom is square root 2 over 1. It's just easier to flip the unrationalized answer. Then what you do is distribute. So negative root 2 over 1 times 1 is negative root 2. And then negative root 2 times negative 1 over root 2 is positive 1. And guys, again, on these, you will have the four choices. The four choices would be 1 plus the square root of 2, 1 minus the square root of 2, negative 1 plus the square root of 2, and negative 1 minus the square root of 2. Again, it's that the numbers are going to be the same. It's the play on the signs that gives you your options. I'm going to erase this because this isn't actually part of what you need. Neither is this. And I don't want you looking at the notes and being confused. Yes, you're seeing double again. Tuning in today, I'm going to make this half of 210 degrees. So my options are half angle or sum or difference. Well, I'm going to use 60 plus 45. Which is easier? I told you at the very, very beginning when we looked at the good tips, this will be the easier method, I promise. Now, the other method is more familiar to you, but if you'll practice the half angle method today, it will be just as familiar, and then you will realize that you are moving more quickly through it. So I'm going to say 1 minus cosine 210 over sine 210. 1 minus. Now, cosine of 210 will be negative because you're sitting in the tangent quadrant. It'll be the same thing as cosine 30. Cosine 30 is square root 3 over 2. Sine 210 is also negative in the tangent quadrant. Sine 210 is sine 30. Sine 30 is a half. The top becomes 1 plus the square root of 3 over 2. Flip and multiply by the bottom, so the reciprocal is negative 2 over 1. Distribute, and you get negative 2 minus the square root of 3. FYI, options, negative 2 minus the square root of 3, negative 2 plus the square root of 3, 2 minus the square root of 3, 2 plus the square root of 3. So it's the same options that you had yesterday. Again, a play on signs. Now, one thing you might want to remember is tangent 105. 105 is in the sine quadrant. So I know tangent 105 is going to be negative, and sure enough, the answer I got is negative. That's a quick way to just make sure that at least your sign seems to be right. On this one, I've got tan 60 plus tan 45. This is a review of yesterday over 1 minus tan 60 tan 45. It's a review, so I'm hustling. Tangent 60, square root 3. Tangent 45, 1. 1 minus square root of 3 times 1. So square root 3 plus 1 over 1 minus square root 3. What do? Multiply by the conjugate. Multiply FOIL method on top. Square root of 3 plus 3 plus 1 plus the square root of 3. On the bottom, FOIL method, or say a plus b, a minus b, is a squared minus b squared. Simplify the top, you get 2 square root 3 plus 4. The bottom is negative 2. Separate and reduce. 2 square root of 3 over negative 2 plus 4 over negative 2 is negative square root 3 minus 2, which matches the answer you already got. Even with me hustling and cutting steps, the second method still took longer. I know you're more familiar with it, but if you'll practice the first method, it will feel equally familiar to you by tomorrow, and then you can use it. All right. We recognized, simplified, and evaluated earlier. We're going to just recognize and simplify now because you're going to be working with letters. This is going to build you up for writing proofs, for solving equations, which you'll get in the next couple of chapters. So we need to be able to work with variables. Now, I'm going to do the same thing I did before. I recognize that this structure is cosine squared theta plus sine squared theta. Well, isn't that just 1? So the answer to this is just 1. Because your 4x's are alike, so it's a single angle that you're plugging into the Pythagorean identity. Now, on the next one, this is cosine squared theta minus sine squared theta. Whoa, that's not Pythagorean. That is one of the 3 expansions for cosine 2 theta. So now I've got to return and simplify what I was given. So I know that what I'm going to get is cosine of 2 theta. Do you see the 4x and the theta correspond to each other? So 2 theta is 2 times 4x. This is cosine 8x. So when you're writing proofs or you're solving equations, this sort of variable swapping is very common. On the next problem, 1 minus 2 sine squared theta is what I'm giving you. Do you recognize that as one of the 3 expansions for cosine 2 theta? So now you've got to condense what you were given. So you were given 1 minus 2 sine squared 3u, which becomes cosine of 2 theta. 3u and theta are in the corresponding positions. So 3u is what I need to put in there. So final answer is cosine 6u. And this does take practice. It usually discombobulates people at first when they see all this at once. Once you practice, it gets a lot better, but this is not easy. The format I've got here is 2 sine theta, cosine theta. Do you recognize that? To me, this is one of the easier ones. It's sine of 2 theta. So I need to simplify what I was given to sine of 2 theta. Well, what's in place of theta? You see the 2v and the theta are in the same position. So it's not sine 2 theta, it's sine of 2 times 2v, which is the sine of 4v. So I'm manipulating variables. Do you recognize that this is 2 tan theta over 1 minus tangent squared theta? That's the format. Oh, okay. Well, I recognize that is the expansion of tan 2 theta. So, do you see that what you've got to say is that I've got tangent of 2. What's in place of theta? If you answered 3x, you were right. Final answer, tangent 6x. On this one, I have the format of 1 minus cosine theta over sine theta. What's that the formula for? Tangent 1/2 theta or tangent theta over 2. Whichever one you like writing better is fine. Now, what's that translate to for this particular black problem? Tangent. What's in place of your theta in this problem? 8x. So my answer on this one's tangent 4x. Almost done. This is a long, tedious lesson, and I know this is really going to require you to do some practice. And I'm trying to hustle so you will have practice time in class. All right, so when I say expand one way here and a different way on the homework, I will circle the step where on the homework you need to start making a different choice. So whenever you have a 3x, the way you start is to say, let me break the 3x into x plus 2x. That's an automatic. And here I'm just wanting you to recognize that there are different ways to expand, and one might be handier than another when you're writing proofs, depending on what you're trying to get to in the proof. And anyway, I'm also wanting you to work with the algebra so you can start to march through the algebra without having issues as you go. So I'm going to expand this to sine A cosine B plus sine B cosine A. Now, your choice is going to come right here. Cosine 2x has 3 options for how you expand it. I want you to pick one option that's different than what I'm going to use right here. So I might say, okay, sine x, cosine 2x, well, I'm going to use, how about 1 minus 2 sine squared x? I'll use that option. So this is the option I'm using in class. You pick one of the other 2 options on your homework tonight. Well, the sine 2x, there's only one option, so that is not going to differ for you. And then cosine x, I rewrite it as it is. So how does my algebra shake out? Your algebra tonight will be a little different. Distribute, you get sine x. Distribute, you get minus 2 sine cubed x. Here you don't distribute, you just clean up the monomial, and that gives me 2 sine x cosine squared x. Take a look at it. If there are like terms, you can add them. If there is a GCF, you might play around with factoring out the GCF. But for right now, we're done. That's good enough for what we're doing. Because again, I'm wanting you to get used to making different options and then working through the algebra that follows. Well, my first step on this one is it has to be cosine A, cosine B, minus sine A, sine B. That's not the issue. Again, and I'm going to drop down just so I don't run into the sine problem. The choice you've got to make is right here. The rest of it, there's only one choice. So I'm going to make one choice here, and then you make a different choice tonight. So I'm going to say cosine x. So this cosine x is this cosine x. Let me say, I'm going to choose something different. I'll choose cosine squared x minus sine squared x. That's different to what I chose in the first problem, right here. You choose on that red step. You choose something different tonight in your homework. And then just play with the algebra. Your answer is going to look a little different. It will be equivalent to my answer. So sine x is here. Sine 2x, there's only one choice. It's 2 sine x cosine x. So now let's clean up. When I clean up, I need to distribute here, so I'm going to get cosine cubed. That wasn't very neat, was it? Minus cosine sine squared. Nothing I can do much there. Now, guys, this part is just a monomial. You don't distribute, you just multiply. It's going to be minus 2 sine squared cosine. But do you guys see that sine squared cosine and cosine sine squared, these are like terms. I need to put them together. So I'm going to have cosine cubed minus 3 cosine sine squared. Or 3 sine squared cosine. The order doesn't matter. Now, I could go further and I could factor out the cosine. That would be a GCF. And that might be helpful. It might not be. It just depends on whatever proof you might be working on. So for right now, we're done. You'd be done at the same point in your homework. But remember, if you make a different red choice, your final answer will look different even though it will be equivalent. So sine of 4x, you can either make it sine of 2 times 2x or sine of 2x plus 2x. Either choice you make is going to work out the same way. So you're going to get to the same point. I choose this one. So this is sine of 2 theta is 2 sine theta cosine theta, recognizing that what's in the place of theta is the 2x. Now, I've got the same choice. Cosine 2x can be rewritten 3 different ways. So I'm going to make one choice here. You make a different choice in your homework. The sine 2x, there's only one method. So sine 2x is only 2 sine x cosine x. Cosine 2x, let's do 2 cosine squared x minus 1. And if you're asking why, the only reason is I've used the other ones in the first 2 problems, so I just decided to keep using variety. That's all. So I'm going to take it slow so I don't mess you up. First of all, I'm going to distribute the 2, not distribute, but multiply 2 times 2 sine x cosine x, and just make that one nice, neat monomial. Now I've got to distribute the monomial times the binomial. So I get 8 sine cosine cubed minus 4 sine cosine. And I'm typically not going to refactor because if I factored out the GCF, I'd be right back to where I just came from. That wouldn't make sense. I'd be going in circles. We are almost done. My computer seems to be just acting a little bit different, a little bit strange. And notice, last 2 problems. And then the double angle, half angle worksheet follows these skeleton notes. All right. On this one, I am definitely, without a doubt, going to start on this side. And the reason is because I have a 3D. I'm going to expand it like I did on the previous problem, and there's never a doubt about that. So, in fact, I'm going to rewrite it as 3x, which you're allowed to do too. I don't want to work with these, so I choose to work with x's and make it like the previous problem. Now, you always, without fail, expand this into x plus 2x. Always. That's what we did on the previous slide. So if I expand, that's cosine A, cosine B, minus sine A, sine B, all over cosine x. So which way do you expand the cosine 2x? You've got 3 choices. If you look at the answer, that might give you an idea because my answer has no cosines in it. Maybe I ought to expand it with the method that has no cosines in it. You're going to get there no matter how you do it, by the way. But some ways just might be faster than others. Hey, look, on the sine 2x, remember there's only one way. Now, I'm going to do something here. Instead of putting this all over cosine x, I am going to separate and reduce. And you might say, why? Why are you doing that? Because I notice monomial cancels with monomial, and monomial cancels with monomial, because the whole fraction, the whole second fraction is just one big monomial term. And that way, what I've got left on the first fraction is 1 minus 2 sine squared. On the second fraction, sine x times 2 sine x is 2 sine squared x, and voila! I get the answer I wanted. So again, I looked at the answer to make a choice about cosine 2x. That doesn't mean that the other choices wouldn't have worked, but I was trying to be intentional about the red expansion. Now, on the last problem, actually, there's quite a few ways you could do this. I'm going to bet most of you are thinking that sine of 2 theta over 1 plus cosine 2 theta would be easier to work with because it seems to be the more difficult side, and I would agree with you. So now we've got to say, well, like, what could I do? I mean, I can't rewrite sine 2 theta in terms of cosine 2 theta because it's not squared, it's not Pythagorean. I can't expand it. Like tangent 2 theta, I can make sine 2 theta over cosine 2 theta. I can't do that here. Oh. Can you multiply by the conjugate? I don't know. Let's see. Remember, when you do this, the one and only reason you multiply by the conjugate is to get something. Can you complete my statement? Pythagorean. As a result, it's best to hold off on the numerator to see if the denominator takes you somewhere. So when I look at the bottom, I get 1 minus cosine squared theta, which is sine squared theta. So wait a minute. On the top, I have sine 2 theta times 1 minus cosine 2 theta. On the bottom, I have sine squared 2 theta. Oh, okay. So I see that the sine 2 theta over sine squared 2 theta, cancels. Okay, cool. So now I've got 1 minus cosine 2 theta over sine 2 theta. Compare, guys. The structure here is 1 minus cosine x over sine x. Do you recognize that as the formula for tangent of 1/2 x? So I take it back and I say this is supposed to be tangent of 1/2 x. What's in place of the x over here? 2 thetas. Oh, half of 2 theta is theta, and that's what I wanted. So, I know it's been a long lesson. I know you're probably a little bit brain dead, but let's work in our groups and see what we can do on the double angle and half angle worksheet before you are out of here for the day. And then I will answer lots and lots of double and half angle questions and some indifference questions when I see you next.